Hey guys, Mr. Martin going over the quiz for tangent lines. Alright, so we'll start with number 1. We need to find k so that y equals k divided by 2x squared is tangent to y equals negative x plus 4. So for this problem, we need to establish two different relationships. The first is if y equals negative x plus 4 is the tangent line, that means it intersects this line. So we have k over 2x squared equals negative x plus 4 at some point. The second relationship is that the slope of the tangent line is negative 1, and the derivative of this equation is the slope function for this equation. So if we rewrite this to be k over 2 times x to the negative 2, and we do its derivative, we get y prime equals negative 2 times 2 is negative k, or negative 2 times a half is negative k, times, subtract 1 from the exponent, x to the negative 3. So we rewrite this to be negative k over x cubed. And again, since the slope of the tangent line is negative 1, the derivative should equal negative 1. So we get negative k equals negative x cubed, which would imply that k equals x cubed. We replace k equals x cubed over here, so we get x cubed divided by 2x squared equals negative x plus 4. So this simplifies to be, really this is x over 2. So we don't need this. So if x over 2 equals negative x over 4, say we add this x over here, we would get 1x plus half x is 3x over 2 equals 4, and if we divide by 3 halves on both sides, we would get x equals 8 thirds. So x equals 8 thirds. Remember, we established a relationship that k equals x divided by, k equals x to the third. So k would equal 8 thirds cubed, which means that, 8 cubed is 512, 3 cubed is 27. So k equals 512 over 27. Number 2, the equation x squared plus xy equals 21 has a derivative so that the derivative is negative 2x minus y divided by x. When y equals 4, find the equation of the tangent lines. So we replace y with 4, we get x squared plus 4x equals 21. We move the 21 over, so we get plus 4x minus 21 equals 0. We factor, we get x plus 7 times x minus 3 equals 0. Let's see, so that would mean that x equals negative 7 and x equals positive 3. If x equals negative 7, the derivative is negative 2 times negative 7 minus 4 over, what's that, negative 7. So that's 14 minus 4, which is 10 divided by negative 7, so negative 10 over 7. And we get a tangent line that is y minus 4 equals negative 10 over 7 times x minus negative 7, so x plus 7. Oh, can't see that. There you go. Excuse me. So then if the other version is if x equals, 3. So if x equals 3, then dy over dx would equal negative 2 times 3 minus 4 divided by, x is 3, so that's negative 6 minus 4 which is negative 10 divided by 3. And the equation of that tangent line would be y minus y is still 4 equals negative 10 thirds times x minus 3. All right. Number 3, for a function whose derivative is 4x squared minus 5x minus 6 divided by x cubed plus 27, determine whether the function has for A, horizontal tangents, and B, vertical tangents. So vertical tangents occur when the derivative equals 0. The derivative is a fraction, and fractions equal 0 when the numerator equals 0. So we would have 4x squared minus 5x minus 6 equals 0. If you're new to factoring this way, you multiply 4x squared times negative 6. We'll say off to the side we get negative 24x squared. We need factors of negative 24x squared that add up to be negative 5x. That would be a negative 8x and a positive 3x. So we get 4x squared plus, that should be a minus. So minus 8x plus 3x minus 6 equals 0. We can factor out a 4x, so that would give us x minus 2, plus we can factor out a 3 for the second group. We get 3 times x minus 2 equals 0. So we get 4x plus 3 times x minus 2 equals 0. In one case, x equals negative 3/4. The other case, x equals 2. Those are our horizontal tangents. We can't find the y coordinate because we do not know the original function. For B, the vertical tangent would be when does x cubed plus 27 equal 0? Well, we know cubic equations produce like a one-to-one function. There's only one value you can cube to get 27. So that means we can just solve x cubed equals negative 27. So that means x equals the cube root of negative 27, which is negative 3. Some of you may have done this by doing a sum of cubes, which will give you x plus 3 times x squared minus 3x plus 9 equals 0, in which case you still get x equals negative 3. If you did the quadratic formula for the second, you would get 3 plus or minus the square root of 9 minus 4 times 1 times 9 divided by 2, and that would be 3 plus or minus the square root of 9 minus 36 is negative 27 divided by 2. This, oh, can't see that. Excuse me. So this produces non-real solutions, so we don't even care. Number 4. For y equals x cubed, the square root of x cubed minus 2x, its derivative is 3x squared minus 2 divided by 2 times the square root of x cubed minus 2x. Find the equation of the tangent line when x equals 2. To write the equation of a tangent line, you need a point and the slope. We already have the x coordinate. To find the y coordinate, we substitute in 2, so we would get y equals the square root of 2 cubed is 8. 2 times 2 is 4, so the square root of 4 is 2. So the point that we have is 2, 2. To find the slope, you substitute 2 into the derivative, so we would get y prime. If you substitute it in 2, that's going to be, what, 3 times 4 minus 2 divided by 2. And we already evaluated this. This already gave us a 2, so 2 times 2 was 12 minus 2 is 10. Divided by 4, so 10 over 4, which is 5/2. So we have our slope and we have our point, so y minus 2 equals 5/2 times x minus 2. For problem number 5, you have to find f4 and f prime for if the tangent line of the graph is f of 4f of x at x equals 4 is y equals 3x minus 7. In class, I wanted you to explain this in words. It would be something like f of 4 equals 3 times 4 minus 7, which equals 5, because the graph of f of x intersects 3x minus 7 at x equals 4, which means they have the same y value. So whatever the y value is for this line, it has to be the same thing for f of x at when x is 4. So we know that f of 4 is 5. We know that the derivative evaluated at 4 has to equal 3 because the slope, because the slope of the tangent line is 3 and f prime of 4 is the slope function evaluated at x equals 4. That's it. Number 6. For x, y minus x cubed y equals 6, its derivative is this. Determine the points where the function has vertical tangents. So vertical tangents occur when the denominator of the derivative equals 0. First rule of factoring is take out the greatest common factor, which in this case is negative 1x. So negative x times 1 plus x squared equals 0. We only get one solution here. Negative x equals 0 implies that x equals 0. 1 plus x squared does not produce a real solution because you would end up with negative 1 equals x squared, and so the square root of negative 1 equals x. We have never in class done anything with, in this case, I, or plus or minus I. So we will continue to not do anything with complex numbers. So we only need to concern ourselves with x equals 0. If you remember, to find the point, you go back and substitute into the original function. If we do that, we would get, if x is 0, that term would be 0, and this term would be 0. So we get 0 equals 6, which is not true. So we have no points of vertical tangency. For horizontal tangents, I want you to find only the x values where the function has horizontal tangents. So let's see, that would be, again, when the derivative is equal to 0, you have horizontal tangents, and then a fraction equals 0 when the top equals 0. So y minus 3x squared y equals 0. It is incorrect to add 3x squared y to the other side and then divide away the y. Rather, you factor out a common factor of y, and you have y times 1 minus 3x squared equals 0. We don't care about the y because it says find the x values. So 1 minus 3x squared equals 0. 1 equals 3x squared. 1 divided by 3 equals x squared, plus and minus the square root of 1/3 equals x. Some of you rewrote this as the square root of 3 divided by 3 plus or minus equals x. That is correct. Oh, there you go. Excuse me. So that is that quiz. If you have questions, I encourage you to go back and watch the video when you have your quiz given back to you on Monday. Thank you.